Assalamu alaikum wa rahmatullahi wa barakatuhu. My dear students, today as a continuity of unit number 14, we are going to speak about alkenes. In the case of alkenes, they are hydrocarbons having at least one carbon double bond carbon bond. That means there is a double bond between at least one pair of carbon atoms. If that nature is there, you can call it an alkene. So there are many alkenes in the world. Fortunately, your syllabus speaks about only the simplest alkene. Who is the simplest alkene? The simplest alkene is the alkene called ethene. So if you take ethene get this structure. So after getting the simplest alkene, the heading, after marking ethene, you need to draw this diagram, C double bond C. So here there is a double bond. Rest of the places are covered by hydrogen. Every carbon, if you take this carbon, it has 4 bonds altogether. 2 bonds between carbon, 2 hydrogen carbon bond, then altogether 4 bonds are there. Okay, right. So that is alkene. After you mark alkene, you come to the heading. You mark the diagram alkene, you come to the heading, derivatives of alkene. Derivatives of alkene. In the case of derivatives of alkene, right, we first introduce chloroethene. In the derivatives of alkene, we first introduce chloroethene. So what is chloroethene? Nothing special. Out of the 4 hydrogens present in the ethene, out of the 4 hydrogens present in the ethene, 1 hydrogen has been displaced by chlorine. Okay, so you have to write the very first thing, chloroethene. This is the molecular formula. So first you are writing the molecular formula. So what is the molecular formula? C2H3Cl. C2H3Cl is the molecular formula. Then you have to draw the structural formula as it is shown in the textbook. Here is the appearance of the structural formula. So that is whom? Chloroethene. What has happened here? Okay, a chlorine atom displaces a hydrogen atom. A chlorine atom, I have used the word atom, displaces a hydrogen atom. That is chloroethene. Right. Another derivative is tetrafluoroethene. Another derivative is tetrafluoroethene. So in tetrafluoroethene, what happens is all 4 hydrogens are replaced by 4 fluorine atoms. So it gets the molecular formula, okay, C2F4. In place of 4 hydrogen, there are 4 H there, 2 carbon atoms are there, C2H4. And the structural formula The same is this way. Tetrafluoroethene. 4-fluoroethene. So remember, the word ethene comes for the C double bond C. Who else is there? It depends. Okay, right. So that is the idea behind the derivatives of alkenes. So completing the derivatives of alkenes, I am coming into the heading polymers. This is a word that you are already familiar. In polymers, many monomeric molecules join together. Many monomeric molecules join together, right? So who is a polymer? A polymer, this is the definition given to you from the textbook for a polymer. Large molecules formed by the joining of large number of small molecules with one another is known as polymer. Remember, the small molecules who make the polymer are called monomer. The small molecule who make the polymer are called a monomer. Okay, making a polymer using monomers is called polymerization. Making polymer using monomers is called polymerization. Okay, right. So you want to know these three words. You want to know the definition for polymer. You want to know the word called monomer. You want to know the word called polymerization. Clear? So these are the three words I am introducing you in this lesson: polymer, monomer, and polymerization. Okay, right. So in the polymers, there are two types of polymers, right? There are two types of polymers there. So we come to the heading types of polymers, right? One, it is natural polymers. Other one, it is artificial polymers. Two types of polymers are there: natural polymers and artificial polymers. Right. Excuse me. I'm getting a call.